This is the continuation of last video. Some errors, the video will be stopped at some stage. So here the nucleophile will be attack backside of this leaving group. Nucleophile attack the backside of the leaving group. The spatial arrangement of these atoms will be changes. That is See, observe, this is attached above the plane, this is below the plane, like means exactly opposite, right? So that this is A. Now this nucleophile will be above the plane, you get Nu, and this B is below the plane, B, then D is on the plane, D. Like that you get. Now here the spatial arrangement is changes, right? Hence it is inversion in configuration. Inversion. So inversion is nothing but what? Exactly opposite to this one. Andre ilivanta above below groups enaithe reverse avoitu. Hence you get retention of configuration. It means the configuration of an atom is totally changes is called as inversion configuration. This is the concept of retention and inversion. Now for example, take a compound of the type in place of A, B, C, D, we are taking a groups like, so observe, in place of A I take hydrogen, and in place of here I take OH group, and here I take CH3. In place of L I take a leaving group halogen, generally write X. Now here in place of nucleophile I write OH. That is nucleophile OH minus in particular example. Now OH is substituted here, the X is eliminated, that is leaving group X minus is eliminated. So what you get here? A compound of the type like H, COOH, and in place of XOH here CH3. Right, so this is called what? Lactic acid. You get a retention. The configuration will be same. Whatever here is there, the same configuration you get. If it is D, you get the D isomer only. If it is L, you get L isomer only. This is the retention configuration. Similarly, here when nucleophile OH is attacked the backside of the leaving group, what you get, the configuration will be changes, right? So nucleophile will attack backside of the leaving group, you get in place of H, what you get H only. So here in place of nucleophile OH, and in place of B COOH, and in place of D what you get CH3. So here if the configuration of original compound is D and the resultant compound is L. Similarly, if L becomes D, means inversion, changes. So this concept is called as inversion of configuration, and this is retention of configuration. Now we are going to study the stereochemical aspects of SN1 and SN2 reaction, nucleophilic unimolecular and nucleophilic bimolecular. There is stereochemical aspects of SN1 and SN2. So let's take first one SN1. Example for SN1 is we are taking hydrolysis of tertiary butyl halide, right? That is hydrolysis of tertiary butyl. T is what? Tertiary butyl halide. Or simply we are taking bromide particularly. So write tertiary butyl bromide C, 3 methyl groups and 1 bromine. CH3, one is above the plane and one is below the plane. CH3. So this is the tertiary butyl bromide. The mechanism of tertiary butyl bromide hydrolysis takes place in 2 steps in SN1, right? The first step is hydrolysis of tertiary butyl bromide, and the second step is attack of nucleophile to the carbocation of tertiary butyl. So here in the first step it is closed step. And you know rate determined step, that is rate determined step or DT or DS, rate determined step or DS. Here after hydrolyzing here what you get C bond CH3 plus P or minus. Here carbon carries positive charge. Observe, after hydrolyzing, these three groups will be same plane. You get carbocation. These having same plane. Whole are in same plane, right? Because the hydration of carbon is sp2. If it is sp2, it called trigonal planar geometry. Right? All these three groups are in same plane. Now in second step, this is this step 1. And in second step, this tertiary butyl carbocation we are taking. All these three groups are what? In same plane. Now we are writing the nucleophile. The nucleophile is what? OH minus. Now here you get two compounds. Observe, what are those two compounds? Here this is in planar, means in triangle. See, this is in planar, like a triangle. It is like triangle, like that. Now we have two chances. The nucleophile will be attacked here, means above the plane, like that, above the plane. Or the nucleophile, that is OH minus, will be attacked above the plane. Or the OH minus will be attacked what? Below the plane, like that. Andre below the plane agi hogi attack agbodu, above the plane allo attack agbodu. Above the plane attack aitu andre one structure bantu, below the plane attack aitu andre you get one more structure. These two are having the different configuration. Those compounds we called racemic mixture. Racemic mixture means one is dextrorotatory, one is levorotatory. Okay, hence in SN1 you get a racemic mixture, but in SN2 you not get racemic mixture. Rather than, or however you get the inversion in configuration. Inversion you get SN2, in SN1 racemic mixture you get. Now observe here, if the nucleophile will attack above the plane, above. If the nucleophile attack below, what you get? So if above the plane, see, above the plane is right, above the plane OH, and one is below the plane, CH3, and remaining two are on the plane, CH3, CH3. Just write it is in tetrahedral geometry, like CH3, CH3, CH3. Okay, you get this one. Now if it is attacked below the plane means right C, below the plane is OH. Okay, remaining three groups are above the plane or on the plane. One is above the plane and remaining two are on the plane. One is here, second and third. So you get two isomers. If consider one is D and one is L. Please write small l, don't write capital N. One is D or plus and one is L or minus. So mixture of these two is called what? The mixture of these two compounds is called as enantiomers. Enantiomers. One is D and one is L. How you get a racemic mixture? That is racemic mixture. So remember, in SN1 you get a racemic mixture because the formation of planar carbocation. But in SN2 you get retention in configuration, not retention, inversion of configuration, that we are studying now. Take the SN2. So in SN2 we are taking hydrolysis of, example we are taking hydrolysis of methyl bromide. We are taking example hydrolysis of methyl bromide. This mechanism involves only one step, right? For SN2. Now take methyl bromide, CH3, that is H and H bromide, Br. So here write one is above the plane and one is below the plane and one is on the plane. This, so like that you can write anyone above or below the plane. Now the nucleophile will be attacked, Mu. Here the nucleophile is what? OH minus. In SN2, the OH minus is attached to the exactly the opposite side of what? Leaving group. Here the leaving group is Br minus. And this takes place in only one step. Here the formation of bond and breaking of bond takes place simultaneously. So now the O and C bond is formed partially and C-Br bond is broken partially. So that you get a transition state like that. C, hydrogen and hydrogen, hydrogen. These three hydrogens are same plane now. Here partially broken carbon bromide bond and partially formed carbon OH bond. So observe, this is not here below the bonds, just we are representing partially formation. This is what? Transition state. Transition state. Now the Br bond, C-Br bond is completely broken and OH-C bond is completely formed, so that you get a compound that is C bond hydrogen. Here the backside is formed bond, that is OH bond is formed to the carbon. Now this is above the plane. Now this hydrogen is below the plane and this hydrogen is above the plane, means changes their positions. One is below the plane and this is above the plane. So observe these two inversion in configuration. Inversion. If it is a D or plus, here you get L or minus isomer. Hence you get inversion in configuration. Inversion in configuration. That is the aspect or concept of stereochemical in SN2. Okay, I hope you understand it. Remember, they may ask for 1 mark. What type of mixture you get in SN2? That is the inversion in configuration. And what type of mixture you get or what is the stereochemical aspect in SN1? In SN1 you get racemic mixture, right? That is equal mixture of D and L isomers. So here the stereochemical aspect is completed.